right, this is Honors Algebra 2 Pre-Calc. We are still doing 1.8 in Algebra 2. So we're going to walk through the steps of solving an absolute value equation. So the first thing to recognize is that fundamentally it's not any different on the onset than solving any other equation. You're going to use SADMAP, right? The difference is that when you get down to the absolute value, you get stuck, and then you have to split this thing into two possible cases. So now in example 1 and P1, which don't exactly match the ones in the book, you're welcome to use the book one as well, we're going to solve for x, and then we're going to actually plot the two answers on a number line. We're doing that because I want you to see the the idea that these things are a certain distance from a value, sort of. Anyway, so once you split things apart into two separate cases, right, so the stuff inside the absolute value could either equal the number or it could equal the opposite of that number, you're then going to solve the cases separately. In a little bit, we're going to talk about a trick case where I give you an absolute value that equals a negative, and we're going to talk about how that works out. Okay, so let's walk through E1 first. Now, the trick with E1 and P1 that's kind of annoying is that you basically ignore this whole first step I gave you in solving, because in both E1 and P1, there is no solving to be done until you get to the absolute value. You're stuck. The second you walk into this problem, you're stuck. So I've already solved down to the absolute value problem. So again, imagine that you can't see what's under my hand. The stuff under my hand could either be a 3, because the absolute value of 3 would be 3, or the stuff under my hand could be a negative 3. So that's what I'm going to write. I'm going to write that there is a positive case where I don't actually change anything. I just write that the stuff under my hand without the absolute value could be a 3, or there's a negative case, right? And in the negative case, the stuff under my hand could be a negative 3. And that's it. I'm just going to solve the two separate cases. So I solve using SADMAP like I would always do. I'm going to add the 5. In fact, the funny thing is you're going to do the same exact SADMAP because it's the same equation on the left-hand side. It's the same in both cases. So when I add the 5, I'm going to get 2x equals 8. And when I divide by 2, I get x is 4, so that's one of my two answers. When I do that over here, I add the 5, right? And when I add the 5 over, I get a 2. So I'm going to get 2x equals 2, so I'm going to get x equals 1, and those are both of my answers. So what's going to happen if I graph these on a number line, there's no shading involved. On a number line, the answers are literally just a dot at 1 and a dot at 4. There's no shading. I need a 1 and a 4. That's it. All right? If you want to try P1 without me, that's great. If you want to walk through with me, I'm about to do it. So same situation in P1. I can't do any solving. There's nothing outside the absolute value. Now, we will do a lot of this step 1 in a second. I'm going to give you other examples. But in the most basic of these examples, there's nothing you can do before you split this apart. So when I make my positive case, the stuff inside the absolute value, 4x plus 1 equals 9. If I do my negative case, the stuff inside the absolute value, 4x plus 1, is a negative 9, right? Because again, what's under my hand could be either a 9 or a negative 9. And then I go ahead and solve by SADMAP. I'm going to subtract the 1, so I'm going to get 4x equals 8, and I'm going to divide by 4 and get x is 2, so that's one of my answers. Over here, I'm going to subtract the 1 and get 4x equals negative 10. When I divide by 4, I'm going to get that either x is negative 5 halves or negative 2.5, whichever one you prefer. And when I graph them on my number line, it's just going to be a dot at each of these because it's not an inequality, it's literally just two answers, and that's it. So what I'm going to do is erase E1 and P1, and we're going to start doing some slightly harder versions of this where we need to use this step 1 a little bit more. And then we will get to a trick problem. So we're going to do the same thing where we solve and graph. I'm just erasing that instruction, but we're going to do the same thing every time, all right? So let's do something slightly harder. So let's do an E2, and again, this doesn't line up with the book, but let's do 3x plus 2. We're going to do minus 4 equals, let's do a negative 1, okay? Yeah, we're going to go ahead and solve this. All right, so before I can solve this, now notice down here I did say that there's a trap if an absolute value equals a negative, but here this absolute value doesn't equal a negative because I haven't solved down to the absolute value yet, right? This is outside the absolute value, so I'm going to deal with that first. So I'm going to go ahead and add the 4 to both sides, right? And I'm going to get the absolute value of this 3x plus 2, which is a locked box, equals a 3. Now I'm stuck. At this moment, I have to split it into two cases because everything else that I could possibly do is inside that locked box. So I'm going to have my positive case, that 3x plus 2 could be a 3. And I'm going to have my negative case that 3x plus 2 could be a negative 3. right? And then I'm just going to solve both of my cases. So I'll subtract the 2 and get 3x is a 1. I'll get x is a third, right? That's one of my two answers. Sorry. There we go. All right, and if I go ahead and subtract this over, I'm going to get 3x is a negative 5. So I'm going to get that the other answer is a negative 5/3, and that's it, right? Those are my two answers. If I want to put them on a number line, here's my negative 5/3. Here's my positive 1/3. Those would be my two answers, right? I'm going to give you a P2 to try that's similar to E2. I'll erase because I used a lot of my board for these instructions that we're going to keep seeing, right? And then eventually I'll erase them so we have some more space. All right, so for P2, let's do negative 2x plus 1 plus a 7 equals, let's do a 15. Okay, so if you want to solve this by yourself, you can. If you want to pause me, that's just fine. I'm going to go ahead and solve it. So this is outside the absolute value, so I need to deal with it first. So I'm going to subtract that 7, and I'm going to get negative 2x plus 1 inside the absolute value equals an 8. So now I'm stuck, right? And I'm going to split it into my two cases. My positive case is going to be that the stuff inside the absolute value is an 8. My negative case is that the stuff inside the absolute value, negative 2x plus 1, is a negative 8. And I'm going to go ahead and solve using SADMAP, right? Subtract the 1 over. I'm going to get negative 2x equals 7. So x is negative 7/2. That's one of my answers. And if I subtract this 1 over, I'm going to get negative 2x is negative 9. So I'm going to get x is 9/2. And those are my two answers, right? So again, if I put that on a number line, it's literally just the two dots, right? A dot here and a dot here. There's no shading, okay? So that's our P1 and P2. We're going to get a little bit more difficult at this, and then we're going to talk about some problems that are really not worth solving by hand. You can solve them by hand, but they're not super duper fun. We'll actually use probably the book's example for one of those. There are some that are much easier to solve on a calculator, and that's what we'll do after we do our E3 and P3. So for E3, let's make this a little bit harder. Let's do a 2 times a 3x plus 4 minus 5 equals, let's do a 7. All right, so let's go ahead and solve this one together, and then I'll give you another one. So again, I'm going to do all the stuff outside of the absolute value. So remember, we're doing subtraction and addition first, because there's two things outside the absolute value now. There's this 2, right? This 2 would be multiplication. That's that operation. And there's this guy that is definitely subtraction. So I have to do subtraction and addition first. So I'm going to get 2 times this whole ugly box of stuff equals a 12, because I add the 5 to both sides. Now I can do that division and multiplication, divide everybody by 2. Well, when I do that, I'm going to get that the absolute value of this 3x plus 4 is a 6. Well, now I'm stuck. Now I'm down to that lockbox and I'm stuck. So now I need my positive case, which is that 3x plus 4 is a 6. And I need my negative case, which is that 3x plus 4 is the opposite of 6. And now I can solve. So I'm going to get 3x is a 2, x is 2/3. Or 3x, when I subtract the 4 over, I get is a negative 10, so I'm going to get x is negative 10/3. Notice I'm not putting a lot of thought into giving you nice, happy answers. Lots of these have come out to be decimals or fractions, and that's fine. So these are my two answers on a number line, right? So I'm going to give you a P3, and then we'll stop this video, and in the next one, we're going to talk about solving. Actually, we might squeeze in one more equation before. So let's do P3, and then we'll see if we can squeeze in one more equation, because we might save the next video for absolute value inequalities, which is the last topic of this chapter. All right, so let's do our P3. Same idea. Let's do a negative 3 absolute value of 2x minus 1. Let's do plus 8 equals... I want to make that a negative 1. All right, cool. All right, so if you want to do this without me, you can go ahead. I'm going to go ahead and start working through it. So I'm going to do my subtraction and addition first. Again, it has to be stuff outside of the lockbox, so I can go ahead and start by subtracting the 8, right? So I'm going to get negative 3 times this ugly absolute value equals a negative 9. And you might be getting nervous about that absolute value equaling a negative, but when you do your division and multiplication, you're going to be dividing by a negative 3, so you're going to get the absolute value of a 2x minus 1 equals a positive 3. Now you're stuck with that lockbox, so you've got your positive case, 2x minus 1 equals 3, or your negative case, 2x minus 1 is a negative 3. When we solve, we'd add the 1 over, so I get 2x equals 4, which is x equals 2. or I subtract I add the 1 over and I get 2x equals -2, my bad, and I get x is -1. So my two answers on a number line would be -1 and 2. All right, so that's your P3. I am actually going to do 2 more videos in this section. We're going to do 1 more video on equations, and then we'll do a video on inequalities. So we'll stop this one here.